All right. So here's the problem. Now, what we were just working on earlier, those problems that we were talking about that were to introduce elimination. I'll bring back a couple of them here real quick. These were set up so that when I added them together, the y's dropped out. This one down here, when I add them together, the x's dropped out. Now this one's a little different because when I add them together, nothing drops out.
So you have to make it even.
I have to do something to set the elimination up now. I have to figure out what I can do to one or the other, or sometimes both equations, in order to force an elimination situation. This is where these problems get challenging. You have to be a little creative because it's not just a pick this number, use it. You have to kind of look at it and think, what's the best one to get rid of? Now, we said if this was a -2, then that would work really well because -2 and a +2, gone. So what we're going to do is we're going to take that top equation, multiply the whole beast by 2. So what that does, 2 times 2 is 4x. 2 times -2 is -2x, and 2 times 7 is 14. 2y. That's what I said, 2y. Now I'm not going to change the bottom equation. 3x plus 2y is equal to a +7. And I'll put the brackets on to show that's still my system.
2 times y, which equals 2y.
Yes. 2 times -y is -2y. And now the advantage to this, when I add them up, the y's are now set up to be eliminated. The hardest part with these problems is always in that setup. Figuring out what you need to multiply by in order to get it so that when you do combine them, something goes away.
Why do you only multiply by this first problem?
Because if I don't need to multiply the second one by it. My goal, if you look right here in the y column, that's set up so that the y's cancel when I add them up. I didn't.
How do you know when you have to multiply by 2?
Because I wanted to be sure that this number up here was going to be the opposite of this number down here.
So always just be a positive, negative.
Positive and negative. Yes, one should be positive, one should be negative, and they have to be the same coefficient.
It was already positive and negative.
Ah, yes, they were. But this one was the -1. This was a +2. Now I've made a -2 and a +2. So when I combine this up, 4x and 3x becomes 7x, 14 and 7 becomes 21, and the y's are gone.
So you always want to cancel out the y.
Well, not always the y. And again, I know that makes it harder, but you want to just get rid of one of them, and you want it to be the easier one to get rid of. You can take the attitude of I'll always get rid of y, but you sometimes make the problems harder for yourself doing that. Because sometimes it's not as easy to set the y's up for elimination. Just back up real quick. If you look back at this example we just did, see how the x's were already set to go? I could make this one where the y's are set up. In fact, look at it. What would I have to multiply this equation by to get the y's ready to go? +3, which set up for that to cancel. But that would make it harder because I'm multiplying when I don't have to. The x's already got set to go. So when I come back to the problem we're working on,
So his order is like add and then divide.
kind of.
And then if it's not ready, then you do multiply, add, divide.
Yeah. Sasha,
Do you want us to check it?
if the problem says check it, check it.
I don't want to check with you.
Problem, some will say do to check, some say won't. Don't. So follow whatever the directions for that item say on the problem on the sheet.
How do you do a check?
How do you check? Well, let's do a check when we finish. So I divide each side by 7. I'm left with x is equal to 3. Now, that means I still have to figure out what y is. So let's take one of the two equations and plug her in. You can plug it in to any equation that's on the page for this problem. I can use this one, I can use this one, I can use this one, and I can use that one. They will all get me the same value for y. Whew. I know, it's awesome.
Wait, you don't, first tell me why you don't use the second?
You don't have to. You can.
Equation that we found that we had it on.
You can use the one you created. You don't have to. I always go back to the what looks like the easiest of the originals, because what it does is it makes my math easier. When you go to the ones that have involved the multiplication, well, there's more stuff there because you multiplied. Subtract 6 from both sides, so I get negative y is 1. Divide by negative 1. My final answer is y is negative 1. My answer, 3, negative 1.
What problem is this? Is it still the same problem?
Yep.
Is that, oh, you're checking it.
Nope. I have not checked my work yet. All I've done, let's go through it one more time. I took,
Checking and be graphing.
No, it's telling you check from x equals 3. So, like,
slow down,
I would never check it.
one thing at a time. I can check it, if I can graph it and see if they intersect at 3, negative 1, that is one way to check it. Remember what we did. Here's the original problem. I took the top equation, multiplied it by 2, so that I had this right here, where I've got ready to eliminate. I combined the equations down to give me this. 7x plus 0 is 21. And then I did some algebra to get x is equal to 3. Once I've got x is equal to 3, I plugged it in to one of the original two equations. Did some work and got what y was. Remember, the objective with all of these problems is to get the point of intersection for those two lines, an ordered pair. You're not done until you write an ordered pair. Now lastly, if the problem calls for a check, take any of the original equations, plug in what you think the ordered pairs are, and see, is it true? Is it true that 2 times 3 minus a negative 1 leaves you 7? Is 6 plus 1 7? Checks out.
That's such an easy check. Yeah.
Mm-hmm.